Rudnicki from University of Białystok, University of Warsaw in Poland. Okay, seems to work. Okay. So yes, please start your presentation.
Okay. Thank you for the second opportunity to present. This is the work of Aneta Polewko-Klim, who, well, we couldn't organize trip for two persons, so I'm delivering this for her basically. So, well, motivation was already covered by my previous speaker, so I will skip that. So we built models for cancer data integration challenge based on molecular data and clinical data. So again, the procedure that was already shown before. We do all the modeling within a robust cross-validation framework. So the first part of modeling is identification of informative variables, and we do it using, in this case, with 5 methods. T-tests, 2 methods based on mutual information, 1-dimensional and 2-dimensional, that includes also information on interactions between variables, and in addition, relief F algorithm and maximal relevance, minimal redundancy algorithms, and then we do identification of informative variables in clinical data. For that, we use different algorithms. It's algorithm based on random forest. It identifies informative variables using as a wrapper on random forest, using random forest importance ranking. And then for quality metrics, we use Matthews correlation coefficient. So we applied 2 methods of combination of data sets. So direct, we rank variables by importance, select 100 most important variables from molecular data set, merge set of relevant clinical variables with most informative variables, molecular variables, and build random forest models. And indirect, again, rank variables by importance, select 100 most important variables from molecular data set, build a random forest model with most informative molecular variables separately for each molecular data set, obtain predictions using this random forest for patients, and then use these predictions as the variable in conjunction with clinical data. Clinical variables, relevant clinical variables. So, first, how our informative feature selection finds. So, it is not very stable. We find in this 50 independent trials of feature selection with 5 different methods, we find altogether 3,738 features in top 100. So, it's not very stable. And for CNV, we don't have so many informative features. It is not, and how they, well, are they the same? Not really. Basically, these 2 information theory-based methods have many features in common. With the rest, it's not really. And relief is very, very unstable. It couldn't find 25 variables. There was no variable that appeared more than 25 times in 50 repeats with the relief algorithm for gene expression. For CNA, only 2, and for CNA, the results are even more diverse than for gene expression, and in particular, there are no methods, no features that are found as most relevant by all of these methods. So, and can we improve the predictions compared to clinical data? So when we have clinical variables, we can build a model on it. And this model is a synthetic model of knowledge already known by clinicians. So can we predict, can we improve on that? And it depends. for direct combination of data sets, it doesn't work. Simply, we basically spoil information from clinicians. But for indirect combinations, we can improve these results a little bit. So using MCC for clinical data only, we have 0.33 MCC, cross-validated, averaged over 50 repeats, etc. And here for clinical plus gene expression plus CNA, we have 0.38. So it is some improvement, not impressive, but there is some improvement. And interestingly, it is even a little bit better than clinical and gene expression only. So, well, it is not statistically significant. It is 0.01, but still, it is just shows that it might be plausible that this can be improved a little bit. And can we find relevant variables? Biomarkers. We have found that eight top genes were repeatedly found by at least 3 filtering methods. And 7 of them, there are genes already found in medical literature as not medical, biological literatures as genes already related to breast cancer. And we found also one new gene that is related in literature to ovarian cancer. We have not found indications that it is connected to breast cancer, but it seems plausible. So these are our results, and the rest of results will be, well, I can discuss with you at the poster number 81, and the Aneta Polewko-Klim made all the work that I presented. Thank you very much.
Thank you for your nice presentation.